In question number 21, in shown circuit, battery is ideal and all capacitors have capacitance of 1 microfarad. Charge Q drawn from the battery will be. We are interested in find the equivalent capacitance between A and B. So let this is point A. The potential of all this point is A and the potential of all this point is B. Let I am considering this junction as X and this junction as Y. So in order to find the equivalent capacitance between A and Y, let I am rearranging this circuit. So this point is X and this point is Y. So one capacitor is between A and Y. So this is, let's see, where the value of C is 1 microfarad. Another capacitor is between A and X. So let this is C. This can be removed. One between X and Y. So this is again C. This can be removed. One is between Y and B. So that is Y and B. One is between X and B. Let this is X and B. And one is between A and B. So A and B is let this capacitor. So we can clearly see about these 2 points A and B, it is a balanced Wheatstone bridge. So this capacitor can be removed. So the C equivalent about A and B would be C and C are in series, that is C by 2. Here also C and C are in series, that is C by 2, and this is C. So it comes out to be 2C. The value of C is 1 microfarad, so it comes out to be 2 microfarad. So the charge Q drawn from the battery Q is equal to C equivalent into V. So 2 microfarad into 12. So it comes out to be 24 microcoulomb. So option 2 is the correct answer. Let's move to question number 22. In question number 22, EV represent electric field and electric potential, then which of the following is true for the figure showing electric field lines? Suppose if I consider a unit cross-sectional area at point A and unit cross-sectional area at point B, then we can see that the number of electric field lines passing through A is more than the number of electric field lines passing through at point B. So EA is greater than EB. Now, from the property of electric lines of force, we know that in the direction of electric lines of force, potential decreases. So the potential at A is greater than the potential at point B. So option 4 is the correct answer. Let's move to question number 23. In question number 23, find equivalent capacitance across A and B. So if I see the given circuit, then it can be easily identified that this branch and this branch is symmetric. So the potential at this point and the potential at this point is same. Similarly, whatever is the potential of this point, the same would be the potential of this point. So the 1 microfarad capacitors can be removed from this circuit, and in that case, if I calculate the C equivalent of the upper branch, then 1 by C is equal to 1 by 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 and so on. So if I find out the value of this GP, so it comes out to be 1 divided by 1 minus 1 by 3. So it comes out to be 3 by 2. So the value of C comes out to be 2 by 3 microfarad. Now this C and this C are in parallel. So the equivalent capacitance across AB would be 2C. So it is 4 by 3 microfarad. So option 1 is the correct answer. Let's move to question number 24. In question number 24, a non-conducting ring has linear charge density lambda is equal to lambda naught cos theta, where theta is measured from the positive x-axis. Direction of electric field due to ring at its center is along. So we can see that when the value of theta is 0, then the linear charge density is maximum. So the linear charge density varies from maximum to 0, then from 0 to negative maximum, that is minus lambda naught, then from minus lambda naught to 0, again from 0 to plus lambda naught is the variation. So we can see that if I consider 2 points, suppose one point is here and other point is here, then the direction of electric field at point O due to these two charges is in this direction. Suppose if I consider some charge at point this and some charge at point this, symmetric in nature, then the electric field at this point due to this charge as well as this charge is in this direction, and due to this charge as well as this charge is in this direction. So the resultant of these two electric field would be in this direction. So we can say that the direction of electric field due to ring at the center is along negative x direction. So option 2 is the correct answer. Let's move to question number 25. In question number 25, a point charge plus 2q is placed just inside a cube corner on the body diagonal of the cube. The electric flux passing through any of the adjacent face close to the charge is. So the adjacent face which is close to this charge 2q is this, this and backside face, and far away faces are this, this and this. So if the flux through the adjacent face is phi1 and the flux through the far face is phi2, then we can write 3 times phi1 plus 3 times phi2 must be equal to charge enclosed divided by epsilon naught. So 2q divided by epsilon naught. So this is equation 1. Now I am considering this charge 2q just outside this corner on the extended body diagonal, somewhere here. And now if the initial cube has an edge length a, then I am constructing another cube of edge length 2a. So let this is the one side. Similarly, it is extended in this direction. So this would be other side. So there are 4 cubes of edge length a, and on this top we kept 4 cube of edge length a, then it will form a cube of edge length 2a, in which the charge 2q is kept at the center. So if I consider the flux through this segment is phi2, then we can see that there are 4 faces at the bottom and there are 6 faces. So 24 times phi2 must be equal to charge enclosed, that is 2q divided by epsilon naught. This is my equation 2. So if I solve equation 1 and 2, then the value of phi1 comes out to be 7q divided by 12 epsilon naught. So option 4 is the correct answer. Let's move to question number 26.